Well, welcome to Tuesday, everybody. Today we're going to be learning about the standard form of a linear function and how we can also change the linear function from standard form to slope-intercept form so it can be graphed. Okay, so go ahead and write down here. I've got some KWL notes that you can pop open and do along with me, or do it in your notebook. And also, here's the assignment for today. So let's go ahead and get right into this. So when you look here at this KWL chart, like all KWLs, it first begins with what it is that you already know. Okay, so our topic is the standard form of linear equation, or the standard form of linear function. Remember, equation and function most of the time can be used interchangeably. So what we already know and what we've been learning and working with for the past few weeks is the linear function. And we've used our linear function in slope-intercept form, which is the model of y equals mx plus b. And we use that particular model when we want to model a single event. Okay, so for example, when we say that Christopher has $80 in his bank account and is saving $25 per month, how much money will Christopher have in 5 months? Okay, so in this example, that is one singular event that's happening where Christopher is saving a certain amount of money per month, and so that can be modeled in the y equals mx plus b form. So y is going to equal, m is my slope or my rate of change. So the $25 per month is what indicates change. So 25x plus $80, which is what he already has in his bank account. And of course, if we were going to find out how much he has in 5 months, we would just simply input 5 in for x. And then that gives us 125 plus 80. So at the end of 5 months, Christopher will have $205. Okay, so that is what we already know how to do and what you all are very proficient at doing. Okay, so when we look here at what we wonder, or what is it that we are wanting to learn today, we say, how can I model more than one quantity or event? So far we've been dealing with a single event. Now we're going to start dealing with multiple events. So we have what we call the linear function in standard form. All right, so the first one was slope-intercept form. This is going to be standard form. And then probably on Thursday, we are going to learn point-slope form. So here's an example of more than one thing happening, okay? And we're going to use the model ax plus by equals c to model and graph these equations. So it says, example, your parents are planning to bring a group of yours and their friends to the zoo. They have $300 to spend. Children under 10 cost $5 and adults cost $10. Write an equation that can be used to model their possibilities. Okay, so what we're going to do is we are going to use this ax plus by equals c model to write this equation. All right, so the first thing that we're going to begin with is assigning to each variable and coefficient within this equation what that value is going to represent. So we're going to start with let x equal the children, because we have two values here. We have a value for children and we have a value for adults. So x is going to equal the children, and we're also going to let y equal the adults. So that's the two values that I have assigned to my variables. X is going to represent the children. Y is going to represent my adults. Now, when you look at this standard form of the linear equation, ax plus by equals c, a and b are your coefficients and c is the constant. So if we start with our coefficients here, we said that we're going to let X represent the children. So the children are under 10 are $5 each. So we're going to write 5X because X is the children, 5 is the amount that they're changing by for each child who attends. The adults are $10 a piece. And we said Y is going to represent the adults. So we're going to put our 10 with the Y because each adult is changing by $10. And then the total amount of money that our parents have to spend is $300. So that is how we model more than one quantity or event happening at the same time. We take the standard form of the linear function, ax plus by equals c. We assign values to our variables. Then we use the information given to assign our coefficients and to model the change. So in this case, 5x plus 10y equals 300. Okay? So the next thing that we're going to put here, having learned that, under our what we wonder is, how can I change this equation into slope-intercept form? Because what you want to remember here is that we are looking for the possibilities that we have. And one of the ways that we can find the possibilities that we have is to change this to slope-intercept form and to graph this particular equation in slope-intercept form, and that will model for us the various possibilities on a line. Okay, so here's how we're going to change this into slope-intercept form. So here it is, 5x plus 10y equals 300. So everybody, all this is this is simply a literal equation. And hopefully you remember back to what literal equations were. This is a literal equation where we solve for y. So if I'm going to solve for y, that means I need to isolate y to one side of the equation by itself. Okay? So if I have 5x plus 10y equals 300, I'm going to subtract 5x from both sides. Now, since I'm trying to write this in slope-intercept form, what I need to remember is slope-intercept form is y equals mx plus b. So this x value I'm actually going to put in front of the 300 when I actually do my next step. So I'm subtracting y from both sides, or x from both sides. Those cancel out. So I have 10y equals a negative 5x plus 300. Okay? So the first thing I'm going to do is move the x. And as I move my x, I am also changing the sign. Because I went from having a positive x to a negative x. So I move the x, changing the sign. And then my next step is going to be to divide by y. So in front of my y, I have a 10. Because remember, I'm trying to solve or isolate for y. So 10 divided by 10 is 1, so that leaves me with y equals. Now, when I look at this over here, I have negative 5x plus 300, all that divided by 10. And because I have here an expression and a whole number, I can actually break this apart and write it as y equals a negative 5x divided by 10 plus 300 divided by 10. And when I do that, this 5/10 is going to simplify to y equals a negative 1/2 x. 300 divided by 10 is 30. So here is 5x plus 10y equals 300 in slope-intercept form. Y equals 1/2 x plus 30. Or negative 1/2 x plus 30. Now, if I come over here to Cami, or Desmos, All right, I can now graph this line. And as you see here, it's going to intersect at 30, okay? Because that's my y-intercept. But what I can also do now is use this line to predict my different values. So I said that x equals my children and y equals my adults. So I can read over here along to, if I have 20 children, that means I can take 20 adults because that's where they intersect the line, okay? If I have 40 children who want to go, I could read up here and intersect my line at 10. So 40 children could go and 10 adults could go. All right. If I were back here, because these are increments of 2, if only 2 children wanted to go, then I could take up to, it looks like, 29 adults. Okay? So that's how you could graph this as a line and then use the line to read your different possibilities. So wherever your x, which represents your children, read up and over intersects the line, that would represent the corresponding number of adults that you could bring to the zoo for $300. All right. So that's how we can change it into slope-intercept form. So let's go here and let's do a few more examples, okay? Let's start with this one here, which is 2x plus 3y equals 12. And I want to change this into slope-intercept form. So remember, I'm going to treat this as a literal equation. And all I'm going to do is move the x. All right. So as I move my x, I need to remember that I'm also changing the sign of that x because I do the opposite or the inverse operation. And I go ahead and put my x in the first place because when I put the x in the first place, that's going to help me write this into slope-intercept form. And then my next step is to simply divide by y. So my y value is 3. So I divide both of these by 3. So that gives me y equals a negative 2/3 x. And then 12 divided by 3 is 4. So 2x plus 3y equals 12. Written in slope-intercept form is y equals a negative 2/3 x plus 4. All right, so if I look at this one here, 5x plus 5y equals 10. Same thing, we treat this as a literal equation. So I'm going to move the x. And as I move the x, we change the sign along with it. So subtract 5x from both sides. And remember, when I rewrite this, I'm going to write my 5x, negative 5x first, because that's going to help me to get this into slope-intercept form. So I move the x, and as I move the x, I make sure that I change the sign, because I'm doing the inverse operation. Then I divide by the y. So 5x plus 5y equals 10 is y equals negative x plus 2 in slope-intercept form. So 3x plus 4y equals 8. Same thing. We're going to treat this as a literal equation, solving for y. So I'm going to move the x. And as I move my x, I make sure that I change the sign of my x using inverse operations. So then I divide everything by the y value. So 3x plus 4y equals 8 is y equals a negative 3/4 x plus 2 in slope-intercept form. All right, so let's summarize what we have learned today over in our L column. Okay, so what we have learned is we've learned how to write the standard form of a linear function and change the standard form into slope-intercept form so the function can be graphed. Okay, so we move the x. Oops. Can't type this evening. Move the x. And as we move the x, we are also going to be put a little asterisk there or star to remind yourself that we're changing the sign. And then divide by y. Okay. So this should be a 2. For some reason, Cami doesn't want to cooperate with me. So there we go. Move the x, change the sign, divide by y. Okay. So that's what we learned today. So what I would like for you to do for your assignment is right here we have the get into slope-intercept form sheet. So there's a total on the front. There's 2 sides to it, 1 through 13. You're just simply changing the equations from standard form into slope-intercept form. And then hopefully you've still got some graph paper that you can graph these equations here. So what you need to do here is to change it into slope-intercept form and then graph the line, okay? So that's what we've got for today. And once you're done, of course, put it up on Canvas for me to look at. Have a great Tuesday, everybody. Tomorrow is Veterans Day. So on Thursday, we will pick up again with changing from point slope form into slope intercept form. All right. Have a great day. Goodbye.